Welcome everybody. I will start and my colleague will take over in a few minutes. So this webinar is organized in the framework of a well-known project that has been going on for more than 20 years in Europe, the ODYSSEE-MURE project, which is supported by the European Commission within the program called Horizon 2020. And it covers more than the EU because there are 31 countries and we are now 27 member states. When we will refer to the EU, we will include the UK, which is in between the two. And the participants to this program, they are mainly energy efficiency agencies or ministries. The project is coordinated by ADEME, the French Agency for Energy Transition, with the support of Enerdata, where myself and Laura is working, and Fraunhofer is here who is working on the policy part. The objective of this project is to evaluate and compare energy efficiency progress by sector in relation to the observed trend in energy consumption and to the EU targets. And the second part is to look at the efficiency policy measures that are implemented and to see what are the best measures. This webinar will mainly deal with the first objective of the project, monitoring the trend in energy consumption and towards the EU target. The project relies on two databases. This is very important to rely on good instruments to make the analysis. The database on energy efficiency indicators, energy consumption data, and all drivers that are necessary to understand the trend in energy demand, and a database on policy measures that gather more than 2,000 measures that are implemented by sector at EU level, including their impact evaluation, which is important to know what has been the impact of the measures. You can find a lot of information on the website of the project. In particular, we have a lot of data tools to bring more insight into the data. And this webinar is based on the data and indicators that have been prepared in the framework of the project. And as I said, they are disseminated through different data tools that are shown here, and sometime I will refer to some of them. We have tried, because policymakers, they like to have very well updated information to make decisions and to understand what's going on. We have tried to update to 2019, which is almost 2 years beyond what we are doing in ODYSSEE now, thanks to data that have been prepared by Enerdata on energy consumption and through a new methodology that we're implementing in ODYSSEE to make advanced estimates of some key indicators that are necessary to the type of analysis we are doing. So you have to keep in mind that information on the year 2018, 2019 are still preliminary, maybe revised. And they will be made public in the data tools in October. So the content of this webinar will be first to describe what are the energy consumption trends. That is Laura that is going to make this presentation. Then I will come back to describe what has been the trend in terms of energy efficiency and to see what has been the role of energy efficiency towards the change in the consumption. And in conclusion, I will try to answer to the question to which the audience has already answered. You think we are not on the track. So I will come back on that later. And I give the floor to Laura. Laura.
Thank you. Yes. Hi, everyone. Thank you.
Sorry.
Yes. So before analyzing energy efficiency trends, we will focus on energy consumption trends. So first, primary energy consumption trends. What we call here primary consumption is the total energy demand of a country. So in this webinar of EU 28, and it covers consumption of the energy sector itself, the losses, but also the final consumption of end users. So here we analyze the trends of primary consumption and also of the GDP. In the graph on the top, we show the trends in base 100 for 2000. And in the graph of the bottom, we show the trends in terms of annual variation for 3 periods. And we choose the periods according to the economic activity, so before the crisis, during, and after. So what we see is that the primary consumption for the EU is quite stable since 2014. And this despite the economic recovery, because the GDP increased again by around 2% per year since 2014. This trend follows a significant decrease of the primary consumption by around 1.5% per year between 2007 and 2014, and this is due to the financial crisis of 2009. Consequently, we show in these two graphs the primary intensity trend. The primary intensity is the ratio between the primary consumption over the GDP. And consequently, the primary intensity is decreasing quite regularly and rapidly since 2007 by around 1.8% per year, which is slightly faster than before 2007. Next slide, please. Yes. Now, if we look at the trends by country, so for the EU member states, here we show the primary consumption and the GDP trends for the period after 2014. And we can see that for 7 countries, the primary consumption is decreasing despite the economic recovery. And for 3 other countries, the consumption growth is quite low, below 0.5% per year. And for all countries, we observe that the consumption is progressing much slower than the GDP. This implies that the primary intensity is decreasing, and for some countries, it decreased significantly. Yes, now if we look at the final consumption trends. So in the graph on the left, we have the trends by sector and for the total for the 3 periods in terms of annual variation. And on the right side, we have the electricity consumption trends by sector also and for the total. We can see that the total final consumption is growing again since 2014 by around 0.8% per year. So this contrasts greatly with the primary energy consumption trend. Now, if we look at electricity, here it grows much slower by 0.3% per year. And this contrasts with past trends, because before the crisis, so before 2007, the electricity was growing much more than the total, by around 1.7% per year. Now, if we look at the trends by sector, we see that the transport sector is the most dynamic one since 2014, with a trend by around 1.6% per year, which is a trend quite similar to the trend before the crisis or before 2007. At the contrary, industry has the lowest progression by 0.2% per year, and industry has been impacted strongly by the crisis, because we have a trend between 2007 and 2014 of around 2.5% per year decrease. Now, the question is, how can we explain the different trends between primary consumption and final consumption? Here, we show a graph showing the drivers of the primary energy consumption variation between 2014 and 2019. For the EU, the main difference between primary and final consumption is composed of the consumption of the power sector. So in the graph here, you see the blue bars representing the primary consumption. On the left side is for 2040, and on the right side is for 2019. and the other bars are the explanatory effects. So the primary consumption increased by only 17 MTOE compared to 50 MTOE for the final consumption. And this much lower progression of the primary consumption is due to two main effects. The first one is a change in the power mix. So the power mix is the share of renewable nuclear thermal plants, as they have very different efficiency. Indeed, producing 1 TOE of electricity with renewables requires 2 to 3 times less energy than with fossil fuels or nuclear power plants. And at EU level, we observe that renewables reached 29% of the power mix in 2019, against 24% in 2014, while thermal share decreased by 3 points and nuclear share by 2 points. So this first effect explains the lower progression of primary consumption. The second effect is the increasing efficiency of the thermal power plants. The replacement of old thermal plants, but also the installation of efficient plants, allowed to achieve an average efficiency of 38% in 2019, which is 2 points higher than in 2014. So these two effects, moving from more renewables and more efficient power plants, contributed to decrease the primary consumption by 23 MTOE and 20 MTOE respectively. Next slide, please. So finally, if we look at final consumption trend detailed by sector and by energy, so first by sector, it's the graph on the bottom. We see that the transport share in total final consumption is increasing from 30 to 34% in 2019, while the share of industry decreased by 4 points down to 25%. And this is quite in line with what we said before, that the transport is the most dynamic sector, while the industry consumption is decreasing. Now, if we look at the energy consumption by energy, so the two pie charts on the right side, we see that as a result of measures to promote the deployment of renewables, their share doubled from 4 to 8% in 2019. Renewables here being biomass, renewable waste, solar thermal, etc. At the same time, the share of gas decreased from 24 to 21% in 2019. The share of oil also decreased, while the electricity of share increased by 2 points. So now that we're seeing the consumption trends, we are going to look at energy efficiency trends, and I leave the floor to Bruno. Thank you.
Thank you. So the question now is, how can we measure energy efficiency in these trends that have been presented previously? So first of all, in ODYSSEE, in this project, we measure energy efficiency progress at a detailed level of subsector and uses through a wide variety of indicators of specific consumption measured in physical units. All our indicators are in physical units to be closer to the assessment of energy efficiency, to get rid of economic factors that may give a wrong signal about the trend in efficiency. So for instance, it will be TOE per ton or gigajoule per ton for steel, cement in industry, liter per 100 kilometer or ton oil equivalent per passenger kilometer for cars, kilowatt hour or ton oil equivalent per square meter for heating, kilowatt hour per household for a wide variety of units. Each time we try to take the most relevant indicators. You can find a description of some of these indicators in one of the data tools that for which I showed the screen at the beginning, the one that is called key indicators. But the question now is, how can we measure energy efficiency at a sector level? We can have trends for the different indicators. So in the household sector, we have a certain trend for a refrigerator, for instance, 2.7% energy efficiency per year. We have another trend for space heating, 1.9% per year in my example. And the question is, how can I combine the trend in these different indicators to get one number as to what has been the trend in energy efficiency in the household sector? And in the framework of ODYSSEE, we have developed a specific indicator that we call Energy Efficiency Index, that is called in ODYSSEE, ODEX, ODYSSEE Energy Efficiency Index. So how is it calculated? First, and this is important, we express the trend in all these indicators of specific consumption by end user subsector in an index of variation to remove the unit. Then we calculate an average index for the sector by weighting each index by subsector with the share of each subsector in the sector's energy consumption. So it's a weighted index of the different index by end use. And the reason why we use an index of variation by end use is the fact that we can use different physical units. We can mix kilowatt hour per household, kilowatt hour per square meter. We don't need to have the same unit. And we can choose each time the indicator that is the closer possible to energy efficiency evaluation, taking into account the information available. The ODEX is presently calculated on the basis of up to 40 subsectors. For instance, 8 modes in transport, 11 end uses for household, 14 branches in industry, and 6 branches in services. Of course, the situation depends on the country. We have a wide variety of countries in Europe. Some have detailed data, some have a bit less data. So 40 is the maximum we provide for the majority of countries, but for some of them, it may be less important. Here you will find a link where you can find more information about the calculation of this indicator ODEX. And by the way, I can mention that this indicator is now part of a ISO standard defining in a standardized way the way to calculate this indicator. Let me give you an example. The case of the household sector. As I told you, there are 11 end uses. We did not show all of them because it would look like a spaghetti. We try to focus on the most important one. And what matters is the red one, which shows you what is the overall trend, the indicator of energy efficiency for the whole sector that is weighted by what is happening in the different sectors. In 2019, the value of this index, the red dashed line, is equal to 67. What does it mean concretely? It means that energy efficiency of household as measured with this index has improved by 33%, 100 minus 67, between 2000 and 2019, which means an average energy efficiency progress of 2.1% per year. Now we do the same for all sectors, and we can calculate the index for all the final consumer for transport, industry, and so on. What we see, again, the total is shown by the dashed red line. Energy efficiency improve a bit less. If we look at all the end-use sector, it improved by 1.2% per year, and also we're above 2% since 2000. And what is important, and this partly answer to the question of the webinar, are we on track, is that there is a significant slowdown in recent years. Since 2014, the efficiency improvement is about 30% less than before. Household is the sector with the larger gains, 2% per year since 2000, as we have mentioned it, but also we see a slowdown since 2014, What is interesting is that during the crisis, the financial crisis that mentioned Laura, the period 2007, 2014, yes, we did not observe a change in the trend, but the trend, there was a disruption in the trend since 2014. Why do we have larger gain for household? Probably because it is a sector which was most covered by policies and the sector at which we have the largest amount of EU regulation that apply to all countries in terms of appliances, in terms of buildings, with several directives that everybody knows in Europe. In industry, we used to have a very rapid energy efficiency progress, but since 2007, there has been a real slowdown since the rate of improvement has decreased from 1.8% per year until 2007 to 0.8% since then. In transport, which is the sector with more rapid demand growth, as was shown by Laura before, we don't see a slowdown, but the improvement is much lower than in the other sector and regular, 1% per year. What does it mean? Through this energy efficiency progress, we have saved energy. And in the project, we calculate every year the additional energy savings that come from this energy efficiency improvement. On average, since 2000, we have saved 14 million ton oil equivalent. This has to be related to the consumption. I will come to that later. What we can see is that these annual savings are fluctuating, but tend to decrease over time, and I will come on that later on. What is important is to cumulate these since 2000. So if we cumulate these annual savings, we arrive at a total of 270 million ton oil equivalent in 2019. What does it mean? It means that without this saving, the final consumption would have been 270 million ton oil equivalent higher in 2019 than what we observed. As I said, there is a slowing pace of energy efficiency improvement, which means that the annual additional amount of energy saving has been regularly decreasing. On the first period before the financial crisis, it was close to 17 million ton oil equivalent per year. Then it has been decreasing to 14.5 million ton oil equivalent per year. One main reason for this change was a big change in industry where the rate of improvement was decreased by a factor 3 almost. And again, since 2014, it is decreasing again. And in that case, it's mainly coming from what happened with household. One third reduction for household in terms of annual additional savings. So the situation is not so good. We save less and less energy. This can be due to the fact that we have reached some saturation. We did the easiest saving. Now it's more costly, more difficult to implement. Or the regulation have not been enforced enough, which I'm not sure. I'm not sure it is a reason, but it could be one reason, and so on. Now, if we relate this saving to the consumption, we can estimate that in 2019, we have saved 25% of the final energy consumption. So it's concrete, and it means that without these savings, the consumption would have been 25% higher. Household, of course, as we have seen, is a sector with larger savings, with almost half of the total saving. And as I said, it's due to the fact that there are a lot of regulation for this sector, plus a lot of national policies, financial incentives, subsidies, and so on. And the sector is overrepresented as its share of savings, which is 46%, is much higher than its share in the final consumption, which is only 27%. On the other hand, savings in transport are much lower than their share in the consumption. 34% of the final consumption is going to transport, but only 25% of the savings were realized in transport, which shows one of the problems we are facing. Transport demand is growing fast, and we are not doing so many savings in transport. This graph, which is a bit complicated to read, try to see how the countries can be shared compared to the average of the EU. We have seen in the EU, 25% of the final consumption is saved in 2019. So we have tried to see what are the countries that are doing better than the average of the EU, what are the countries that are doing a bit less. In green, on the top of the screen, correspond to countries which are doing better. And you have a zoom on the right side of the right bottom side of the screen for the countries with a small level of consumption. And what we can see is that the long-standing EU member states like Germany, Italy, and France have a relatively lower share of energy savings than the EU average. One of the main reasons is that they started a long time ago to implement energy savings compared to the new members that are doing better, above 25%, but that have embarked more recently in energy efficiency policies and benefited, of course, more from this more recent effort. Now, let's go to the explanation of the change in the final consumption, this decomposition tool, which is quite popular because it helps understanding why the consumption is growing for countries where it is growing, why it is decreasing in case it is decreasing. So here, this graph shows you what has been the variation of the final consumption between 2014 and 2019. It has increased by 50 million ton oil equivalent. This is not good because we have target to reduce this consumption. I will come back to that later. It is increasing. And there are mainly two factors. And the weight of the factor depends on the period. You can see on the, you can check on the website of the project, the tool, and there is a possibility to play with the period, to play with the different parameters. And it is interesting to see that depending on the period, the importance of the different effects can vary a lot. On this period, two main factors contribute to explain the variation in the final consumption. The first one in orange is what contributes to increase the consumption. It's economic, demographic growth, the improvement in lifestyle of household, and so on. All this contributed to increase the consumption by almost 100 million ton oil equivalent. But the consumption only increased by half. Why? Because of these energy savings, which offset more than half of this activity effect and reduce the consumption by 50 million ton equivalent. So this graph enabled to make the link between the first part of the presentation on the trend in consumption and the second part, which was on the energy efficiency and energy savings. Now, if we look on a longer period since 1990, and then we are back on the primary consumption. The real primary consumption is shown by the red line, and it is broken down by fuel. In blue, you have coal, in orange, oil, in gas in blue, and so on. And on top, we have added the savings in green. What we see is that in 2019, without the savings, the primary consumption would have been 27% higher. And if we look at the share of the different fuel in this mix, we can see that energy saving is the first fuel, 27%. The second fuel is oil, 23%. So it's 4% more than oil. This is why we can say that energy saving is the first fuel in the primary consumption in 2019. Usually we don't see it because by definition this has not been consumed, but this type of graph that is now quite common aim at showing what is the invisible part of the consumption. Now, I want to show you why it is important to work with physical indicators. I show here the trend is the final energy intensity, that is the ratio between the final consumption and the GDP. And since 2014, on the right part of the graph, you can see that only half of the reduction in this intensity is due to energy efficiency. The rest, that is shown in orange, correspond to different type of economic changes, which we call structural changes. It can be the fact there are higher share of energy intensive industries. The fact that services is taking an important part in the economic activity. And of course, services on average require 7 times less energy than industry to generate €1, $1 of GDP. There are saturation effects, also the fact that a lot of households are already equipped by, in terms of durable goods, and the increase in the number of equipment is much less. Or the fact that there are more and more products with high value added, which doesn't increase the consumption, but decrease further the energy intensity of these industrial products. Before 2040, most of the intensity decrease was due to energy efficiency improvement, around 80%. So we can really see that since 2014, we have a different trend compared to the year before, and especially lower role to energy efficiency in the change of the energy intensity. So if policymakers are just interested in decreasing the final intensity, they don't care. What matters is the result. If they are interested to improve energy efficiency in a long-lasting way, then this message is important to take into account. Now let's go to the conclusions. How we got off the track. At EU level, like in most countries, we have energy efficiency targets. Energy efficiency targets are always difficult to define. They vary quite a lot from one country or to the other, depend on the period of time. And we can express them in different ways as follows. First of all, the most common way before was energy intensity reduction. This is not much used anymore, and not at all at the EU level. Why? Because as I explained before, this intensity can reduce, but it may not be linked to energy efficiency. So it is not really a good indicator for energy efficiency policy. Second way is to set a target as to reduction of the energy consumption compared to a baseline projection. This is quite popular. The third one is to give a target in terms of energy saving. This is what we did at the EU level for some time, but the problem is that it is difficult to measure this saving. You need to agree on a methodology, which turned out to be very difficult to get harmonized methodology accepted by all countries. This approach in terms of energy saving, this is what we are doing with ODYSSEE, but imply a certain methodology. The fourth type of target is to fix a level in the energy consumption in absolute terms, so a kind of cap on the consumption. Compared to the second type of target, the second type of target is built according to a baseline projection, whereas the fourth indicator relates to a level, so the consumption should be 20% lower than in the year 2005, for instance. So it is more stringent, more difficult to achieve. The EU is using the three last type of targets in a complementary way. at EU level, we refer to the EU Energy Efficiency Law as the Energy Efficiency Directive. This is the official name in Europe. And we have the following target. First of all, 32.5%. You can imagine it's a result of a big negotiation to arrive at such a not a simple number. Energy saving target in 2030. And we had before the 20% in 2020. This is the target for the EU as a whole, and it is measured compared to a baseline projection. I will explain that later on. That was made in 2007, so before the financial crisis. Then we have savings. So it corresponds to the third type of target, 1.5% of per year additional energy saving until 2020, and 0.8% until 2030, over 2021, 2030. This should be obtained from energy saving obligation with energy companies. It means that energy companies are obliged to make saving from their consumers, and the amount of energy saving to be obtained should be calculated so that it corresponds to 1.5% of the consumption. But this was the spirit of the Article 7, but many countries did not agree, did not want to put a constraint on their utilities. So it has been amended in such a way that it can include other policy measures. But this 1.5% saving means that the saving should be policy related and it should be demonstrated to be policy related. And we have a third target, which is a cap on the primary and final energy consumption that should be proposed by country. It's called Article 3 of the European Energy Efficiency Directive, and is done in a way that it is consistent with the first target of 32.5%. Now let's see how it looks like. Here you have on top in orange the trend in the primary consumption. This is what Laura showed before. When we deal with consumption, there are two ways to measure the consumption. Just take the statistics. This is what we call at real climate, but it fluctuates depending, because in Europe about 60–70% of the consumption is going to space heating. So it fluctuates with the climate. If we have a very severe winter, the consumption will increase. If it is warmer, it will decrease. So to avoid this, in ODYSSEE, most of our indicators are calculated at normal climate. We correct the consumption at to see what would be the consumption at normal climate, so that the trend is independent of the climate. Well, in the directive, they work with data at real climate. You will see it will have a little impact. Then you have the baseline projection that is called PRIMES 2007. This is a reference that is used in directive made with the PRIMES model. And the target was set in 2020 to be 20% lower, and in 2030 to be 32.5% lower. So this target of 32.5% doesn't mean a reduction in the consumption, but a reduction compared to baseline projections. This is important to understand that. And below, in blue, you have the final consumption, and with a similar type of target. First thing, we can see that in 2019, we were close to the 2020 efficiency target, 4% above for the final consumption, and 3% above for the primary consumption. Well, given the fact that we'll have a big drop in the consumption in 2020, I think this target is not meaningful anymore, because we will reach it because of the deep economic crisis. Second thing I wanted to say is that we have winters that are warmer and warmer, and this help achieving the targets because they were not defined taking into account climate correction. And for instance, it increased by 1 or 2 points the discrepancy compared to the target. So the warm winter helps us to be 1 point closer to the target. If we look at 2030, it's clear that the trend do not enable to reach the 2030 target. For the primary consumption, the recent trend is going down thanks to renewables, but this is the final consumption that is more worrying. It is increasing. You have seen plus 50 million ton oil equivalent since 2014. You can see it here on the graph. And we are not on the path to go towards the values that is shown by the green circle in 2030. Now, if we look at the savings that correspond to the Article 7 of the Energy Efficiency Directive, the 1.5% additional savings. There is a monitoring now that is shown here in orange that is compiled from the country submission, but it stopped in 2017. In ODYSSEE, we can calculate the savings according to Article 7, applying the same kind of definition, because in the way it is stated in the directive, there are cumulated savings every year. So for 3 years, we have 3 times the yearly saving, more or less. And in 2017, we are at 40% of the 2020. It seems we will be below the target, but the country may say, well, we have recent policies, so the situation could improve in the most recent years, so it's more difficult to conclude. Then if we look at the blue bar, which is calculated, and the dash because it is estimated, calculated from ODYSSEE, actually the number we get from ODYSSEE are above the target of the Article 7 in 2019. But this is not comparable. This is what I wanted to, on what I wanted to draw your attention. What we measure in ODYSSEE with indicators are all types of savings, not necessarily policy related. They can be due to autonomous progress, the fact that when people replace an equipment, they only find more efficient equipment. So this is autonomous progress. It is not necessarily related to a policy. So the savings measured according to what is related to policy, usually they are lower than the total saving we measure in ODYSSEE. Conclusions. Since 2014, the situation is quite good for the primary consumptions, thanks to the penetration of renewables, the fact we have more efficient thermal generation. We are closing coal power plants in Europe, replacing that with gas power plant, gas combined cycles, which are more efficient. So this limits the increase in the primary consumption. But the situation with final consumer is much less favorable. Energy efficiency improvement is slowing down, especially for industry, but this started at the moment of the financial crisis, and there was not recovery from that time, and since 2014 for household. Household is the sector that is performing the best, which shows the effectiveness of policies. This is a sector with a larger number of regulations, and which have been also regularly upgraded. This is important to mention that. Just not important to have regulation, but they should be regularly reinforced, which was the case. So to conclude now and try to answer to the question that was raised at the beginning, have we got off track? Well, with respect to 2020, we cannot conclude because due to the COVID crisis, the consumption will decrease probably by almost 10% in 2020 in EU countries. According to the latest GDP forecasts from both the IMF and the OECD for the moment that was published yesterday for the IMF, the GDP will decrease by 10% and even more in the large EU countries. So this will have a big impact on the primary consumption. So now we should focus on the EU target because fortunately we can expect a recovery. And according to what we see, the EU target for final consumer will not be reached with the present trend and require additional measures. And this is the purpose of this Article 7 to give incentive to the country to implement more and more measures. Now I think I will stop here and I thank you for your attention and I'm ready to take questions.